Hello, welcome to another video. This is a video on guidelines for curve sketching, and I have thought through it and I felt it's better to go in order the way it gives you speed and you don't have to wander around. So I came up with this acronym, DISLAMIC. Now, the reason why I did that is the domain is the first thing you need to think of for any graph you're sketching. And then you can go through the entire sequence of things to calculate or to know so you can get a precise shape of your graph. Now, because this is a polynomial, it's easier for you to do even by looking from based on the knowledge you gain from pre-calculus or algebra. But you notice that you will not be able to tell where the concavity changes. You can tell what the maximum is once you go past a parabola. Calculus helps you to be more precise, and your teacher expects you to show how you know those points by using these calculus concepts. Actually, many of them are from pre-calculus or algebra. Okay, they're just few calculus points. Remember that if this question shows up for you to sketch and to use the guidelines, you have to show this work, and most of your points will come from this and not the graph. So if you jump to sketching the graph, well, you have sketched it, but that's a pre-calculus sketch. You have to do the calculus sketch. Okay, so I'm going to start from domain and we end at concavity and eventually sketch it. So let's go. So the first task is to determine what the domain is. It's always smart for you to know what kind of function you're dealing with, because this is a straightforward polynomial, the domain of any polynomial, from negative infinity to positive infinity. No numbers are skipped, no numbers are problematic. You can plug in any real number on the number line and this works. So we can go here and say that the domain of this function is from negative infinity to positive infinity, and we are done. And just by knowing that, we can answer the question of asymptotes. Because remember, the vertical asymptotes are those x values you must avoid so that your function doesn't have a problem. So we do not have any vertical asymptote. So that makes our life a lot easier. No vertical asymptote. Vertical asymptote is none. Okay, now do we have horizontal asymptote? Do we have a horizontal asymptote? Is there a number that we're approaching as we keep going to infinity? Well, we have to determine that later when we get to asymptotes. Okay, but let's go here. What are the intercepts? Now, one thing I want to say about intercepts is always start with the easier one. Start with the value of y when x equals 0, because it's easy to determine. You just need to plug in 0 into whatever function you're given. Find the value of y when x is 0, and that's what we call the y-intercept. So always start with the y-intercept, okay? So the y-intercept will be, we say y is equal to negative 1/3 of 0 cubed plus 0 squared. Well, there's going to be 0, 0, that gives us 0. So our y-intercept is y equals 0. Come back here and say y-intercept is y equals 0. And then we can go back and find the x-intercept. So for the x-intercept, all you have to do is say, what will be the value of x when y equals 0? So you go back to the function, put 0 here and try to find what x is. Okay, so we're going to say that negative 1/3 of x cubed plus x squared is equal to 0. So it's going to be x squared times negative 1/3 of x plus 1 equals 0, right? So x equals 0, or this is equal to 0. If you solve for x here, you notice that x has to be 3, okay? You can go here and say this implies 1 minus 1/3 of x equals 0. You multiply everything by 3, you have 3 minus x equals 0, which means x equals 3. That's the other one. So you've gotten your x-intercepts. Let's talk about symmetry. Why do I have to determine the symmetry of a graph? Well, it's because it helps you. Some graphs are so complicated that once you can sketch one side, the other side looks exactly like this side. You just copy and paste. You don't need to do anything else, okay? But it helps you. And sometimes you just need to know symmetry, because when you get to integration, yeah, symmetry becomes a tool that saves you from stressful computation. So let's do that. In order to know whether a function is symmetric, remember, we're going to rewrite this as f of x, okay? So f of x is negative 1 over 3 x cubed plus x squared. But we're going to change this to f of negative x and see how they relate. So a function is symmetric if f of x is the same as f of negative x. It is, yeah, that's all I'm going to say. It's symmetric if that's the case, okay? If f of x is the same thing or a reflection, okay? There has to be some consistency. So let's see. F of negative x will be equal to, what do we have? Negative 1/3 of negative x cubed plus negative x squared. Let's see how this turns out. This is negative 1 over 3 times negative x cubed plus this is going to be x squared. Well, this negative will cancel this out. So you have 1 over 3 x cubed plus x squared. Is this the opposite sign of this? The answer is no, because we have switched the signs on this one, but we didn't switch the signs on this one. So there's no symmetry. Typically, it's either the same exact thing or the complete opposite, but this is a partial opposite. That means it is not symmetric. Just remember that. So this function is neither odd nor even. Okay? So here, no symmetry. No symmetry about the y-axis. About y-axis. We're done. What about limits? Remember I talked about how the function behaves as you approach a vertical asymptote. Unfortunately, we don't have a vertical asymptote, but every function always has a horizontal asymptote. It is either a finite number or it's infinity. We got to discover what this one is. So let's go here. And the limit helps us decide the end behavior of the function. As you approach infinity, how is the function behaving? As you approach negative infinity, how is the function behaving? And that's the whole point of this one. You want to know what happens at the end. Isn't the end always the most important? Okay, so if we look this way, we're going to notice that this goes to negative infinity because you have infinity. If this goes to infinity times negative 1/3 gives you negative infinity plus infinity. So you end up with something like this, negative infinity plus infinity. Well, you can't do a subtraction, so you can't write it this way. You cannot subtract infinity from infinity, so you can only multiply and you can only add. So we're going to rewrite this in a way that we're multiplying, not dealing with this subtraction. So this is going to be you notice that this is going to go to, or let's put it this way. This is going to be equal, let's put it this way, this is going to be equal to the limit as x goes to infinity. I'm going to factor out whatever is common there so I can make a product out of them. It's going to be x squared times negative 1 over 3x plus 1. So the way this is, we know that x squared is going to go to infinity. And we'll be multiplying by, this goes to infinity times negative will be negative infinity plus 1, which is still negative infinity. So now we can multiply this, and our answer is going to be negative infinity. So as x goes to infinity, the function goes to negative infinity. As you go to the right, the function goes down. So we go here, we're going to say the limit as x goes to infinity. Okay, I'll leave it there of y. Let's write y here. Okay, so about the limit as x goes to negative infinity of y. Where does it go? Let's go do the same thing. So we have this expression. We're going to say the limit as x goes to negative infinity of this expression of y will be equal to the limit as x goes to negative infinity. We have x squared times negative 1 over 3x plus 1. Negative infinity squared is going to go to infinity. And then negative infinity times negative would be positive infinity plus 1. That's positive infinity. So this goes to infinity. So as we go to the left, this goes to infinity. Nice. Okay, we're going to have this go to positive infinity. Okay, so those are our answers. Maybe I should put lines between these before they get clumsy. Now, this is our horizontal asymptote. That's what you call your horizontal asymptote. It is the number that it's approaching, but we don't know what that number is because it's infinite. So that's a horizontal asymptote. Or you say none. Basically, because it's not finite, most people say none. So I would rather say none. No horizontal asymptote. Okay? Or you can say it's infinite because it doesn't exist actually. Infinity does not exist. I don't care. Okay, let's go to the next one. Max and min. So remember that your maximum and your minimum occur when the derivative is equal to 0. So we just need to do y prime. What's the derivative of this is going to be negative x squared, and there's going to be plus 2x. Okay, and I'm going to leave negative x plus 2. The only way this is 0 is if x equals 0 or x equals 2. These are the two values of x where the maximum occurs, but I would strongly recommend that you actually find the points. We know the x values. What would be the points? So the points are at x equals 0, y equals something, and x equals 2, and y equals something. Let's go find those points, because that's what you will point, you will plot. So don't just get the x, you need to find the maximum points. What do we do with these two values that we've got? We need to do our sign chart. We need to do our sign chart so we can discover which one is the maximum, which one is minimum. Okay? So what we do is we look at the critical number. So these values are what we call our critical numbers. Critical numbers. Okay? They're the numbers around which things change. Things change. They're critical numbers. Okay? So we'll put 0 here. We put 2 here. And then we're trying to see the behavior of the slope. Because if the slope goes from like this to like this, then we know that point is a minimum point. Okay? And if the slope goes from like this to like this, then we know that point is a maximum point because things are going up and then they go down because that was the maximum. So we just need to look at the shape. So this part that you solved equal to 0 is what you put here as a product. So we're going to have x, and we're going to have negative x plus 2 can be written as 2 minus x. So what you're going to do to decide if this is maximum or minimum is, hey, if I pick a number less than 0, then x will be negative. If I pick a number between 0 and 2, x will be positive. So I pick 1. Always narrow down your number to a very convenient number in the interval. If I pick x after this is still going to be positive. So now let's pick a specific number. A specific number here will be negative 1. If I put negative 1 here, it's going to be 2 minus negative 1. That's going to give me 3, which is positive. If I do the same thing here, if I put 1 here, it's going to be 2 minus 1. It's going to be positive. If I put a number here bigger than 2, let's say 3, 2 minus 3 is going to be negative. So based on what I see, the slope here is going to be this times this, which is negative. So a negative slope always goes this way. Okay? And then here, positive times positive, it's going this way. So obviously, you can tell that this is a minimum point because the slope has changed direction. So this is a local minimum. You call this a local minimum. And then, because it has surroundings. Now, if you go here, you multiply this, there's going to be a negative slope. So this looks like a local maximum. Local maximum. So now we can go back here and say, we know that when x equals 0, we get a minimum. So this is 0. What will the value of y be? Well, let's go plug in 0 here. I think we did that before. When x was 0, y was also 0, which was that's the origin. So the minimum of our graph, the local minimum has to be the origin, and then we go to the local maximum. It's going to be where x equals 2. When x equals 2, what are we going to get for y? Let's quickly plug that in. There's going to be negative 1/3 of 8 plus 4. So it's going to be 4 minus 8/3. What would that be? That's going to be 12 minus 8. Oh, it's 4/3. 4/3. 4/3. Positive. Okay, so that's it. Now, intervals of increase and decrease. See, the good thing about this method is you don't need to do any calculation. What are the intervals of increase and decrease? Well, this one is telling you. This is the interval of increase. This is an interval of decrease. This is an interval of decrease. So we just go here and we say that interval of increase, this is the short form of it, will be from, it's going up from 0 to 2. From 0 to 2. Interval of decrease, let's write it here. Interval of decrease will be from negative infinity to just before 0. And then from, let's do union. I like union here. You don't have to do union. You can just put a comma between them. And then you're going to have from 2 to infinity. From 2 to infinity. That's what you've got. One more thing, and then we sketch. By the way, if you get here in all of the work we've done, I tell you, you've got at least 70% of the grade. Let's go. The last thing, concavity. When is the graph facing up? When is it facing down? And where does that change? That's all you got to do. And all you have to do is take the second derivative. The second derivative of this function will be, we differentiate this, it's going to be negative 2x. We differentiate this, it's going to be plus 2. Well, when this happens, the same thing we did when we found the first one, we equate this to 0. So 0 is going to be negative 2x plus 2. That means that 2x equals 2. That means x equals 1. So at 1, something definitely happened. We got to investigate. We just need to know if it's positive or negative. Let's write this as 2 times 1 minus x. Okay? It's always good to have a product form when you're doing things like the intervals. So we're going to do the same thing. The most important number here, and the only one, is 1. So we're going to say 2 times 1 minus x. Here, 2 is always positive. It doesn't change on this interval, but 1 minus x might change. So let's pick a number that is less than 1 to the left of 1. If we put 0 here, 1 minus 0 is a positive number, so this is positive. And anything positive for concavity is facing up. We go here. What is this? This is, we put a number beyond 1. Let's say 2. 1 minus 2 is negative. Okay, so this is going to be facing down. And that's it. We have found everything as far as concavity is concerned. Let's give this one its own room. So concavity is, you have this, and you have this, and this is from, and then the number here. So this point here, I forgot, this point here is called the point of inflection. X equals 1 is the point of inflection. The point of inflection is where concavity changes, and that's it. So you have this, you have point of inflection. So this goes from negative infinity to 1. And this goes from just 1 to infinity. Okay, basically that's what you have. And this point here is 1. Point of inflection is x equals 1. Okay, now let's sketch the graph. Now the table is set. The first thing is you want to identify all the intercepts. You know something is going to happen at the point y equals 0 and the point where x equals 0 and where x equals 3. You want to quickly identify those points. So something is going to happen here. Something is going to happen here. Okay. We also know that something is going to happen at this point here. Okay, something is going to happen at x equals 1, well, along the line, because that's where something happens at x. So something is going to happen somewhere here, because that's where concavity changes from facing up to facing down. What about our maximum points? Just go to all the points. A maximum point, the minimum point, minimum. A minimum point is point 0, 0. So when this is a minimum, it means there's going to be something like this. Okay, just to help yourself, that's a minimum point because it's going to do that. And then a maximum point is going to be where it changes direction. So it's at 2 and 4/3. 4/3 is 1.3. So 1.3 should be somewhere here. So, and it happens at 2. So it's going to be somewhere here. See, it's beginning to look promising because now it looks like there's going to be an inflection here where this graph is going to face down starting from here. So starting from here, and it's going to come back and do the intersection here. So you're going to have a face down, something like this. And this is going to face down here at this point. No. Yeah, that's it. At this point, and then it's going to face up. Ooh, nice. I'm a genius. Did you see that? We're almost done. What else do we need? I just need to pull this up, but I don't want to be too weird, so it's better for me to just pick a number on this side that's easy to deal with. So if I pick 1 here, -1 rather, if I put -1 here, this is going to be 1/3, and this is 1, so that's going to be 1 plus 1/3 will be what? What's that? 4/3. So 4/3, oh, it's about the same height as this. So around here, I can just pull this up. And that's my graph. You see why this doesn't give you so many points? Because it's easy to do once you get the most important things. I'll see you in the next video. Never stop learning, because those who stop learning have stopped living. Bye-bye.